So over the last couple classes, we've talked about factoring and solving polynomials that have specific patterns or tie back to the quadratics that we've done in the past. So on this video, what I'm going to do is I'm going to give you a little bit of review. This was intended to be our warm-ups for next class, but what I'm going to do is use this as just a review video, and then we'll be able to go over some homework problems if you have any during class. So we have these three equations that we are trying to solve. So if you want to try them before I do them, please pause the video and then we'll go through the answers. So the first one, if I'm trying to solve this polynomial, first of all I notice that there are four terms here. There's not two terms, so it's not going to be a sum of two cubes or difference of two cubes like we saw in the other video. It is also not going to be like an old quadratic because it has four terms. That's more than the quadratics used to have. What we're going to be looking at with this one is factor by grouping. So this is the factor by grouping method that we looked at during our patterns of factoring polynomials. So factoring by grouping says, basically you're going to divide this problem into two groups. We're going to look at this group and this group. That's one of the reasons four terms, or an even number of terms, is helpful in this case. So what I'm going to do is I'm going to look at the first group and say, okay, both of these have an x squared in common. What we mean by that is both of them can be divided by x squared evenly. If x squared is divided out of x cubed, remember dividing like bases, you subtract. 3 minus 2 would be 1, so it would be x to the first. 7x squared, if you divide x squared out of this one, x squared comes out completely to plus 7. Remember, you can always check by multiplying x squared times x to get this, x squared times this to get this. That is just how you check using the distributive property. Then we look at the second group. The second group, you can divide a positive 4 out of both of these. So when I say dividing a positive 4 out, the reason I put the plus 4 is for my next step, really. But it's also reminding myself I'm dividing by positive 4. 4 divided by 4 is 1x. 28 divided by 4 is plus 7. When you are factoring by the grouping method, the thing that has to be the same is right here and right here. Your binomial factors inside the parentheses have to be the same for factoring by grouping to work. If it is not, then you cannot use grouping. We will talk about those later in the chapter. If these are the same, what we can do is now we can take x plus 7 and factor x plus 7 out of the entire problem. Or in other words, we can factor out x plus 7 out of the first group, factor out x plus 7 out of the second group. Notice what we're not doing. We are not just sliding parentheses around all over the paper. We are literally dividing x plus 7 out to the front. If we do that, if you divide x plus 7 out of this group, x squared would be the only thing left. If you divide x plus 7 out of this group, 4 would be the only thing left. What I mean by that, just real quick, if you divide this group by x plus 7, this cancels out. X squared is the only thing left. Same thing for this group. So when we say we're dividing it out, factoring it out, it's just like when we factor something really simple out to the front. We put it in the front, and then we write what's left in the other parentheses. X squared plus 4 cannot be factored anymore. Even though I know a lot of you want to do x plus 2 and x plus 2, x squared plus 4 would not work because there's no middle term here. If it was minus 4, you could do x plus 2 and x minus 2. The step of solving means we take this one step further here. Once we get it factored, we set our factors equal to 0. Remember, that comes from the zero product property that says if you have this factor times this factor and it equals nothing, one of them has to be nothing. If you multiply two things together and you get 0, one of those things has to be 0. And so what we've done is we've taken this ugly polynomial that's a cubic polynomial, and we've broken it down into two smaller equations, linear and quadratic in particular, because we spent a whole semester solving those. So we take this and we subtract 7. One of our answers is -7. On the other one, we subtract 4 to get the x squared by itself, take the square root on both sides, and we get x is equal to plus or minus. Don't forget, whenever you solve using a square root, you have to remember that it can be a positive or negative answer. Even though this one's weird, the square root of -4 is not normal, because the square root of 4 is 2. The square root of -4 would be 2i. Remember, anytime you have an imaginary, a negative number inside the radical, it becomes an imaginary answer. So we have two answers here, and we have one answer here, for a total of 3 answers. We're going to talk about that a little bit more as we go through the rest of the chapter as well. On the second one, if you are factoring this one has 3 terms. So this is not factoring by grouping. What I talked about in class is that this one is factoring by what we call a quadratic form. Notice it's not a quadratic though. It is a quartic because it is x to the 4th power. But it factors very similar to what we did with quadratics using that FOIL method or distributive property, reversing it backwards. In other words, the first term here is x to the 4th. The middle term is x squared, which is half of x to the 4th. We can split up x to the 4th into x squared and x squared. Very similar to what we did back in the quadratics chapter when we split up problems into just x and x because the middle term was just x. This one we have x to the 4th because the middle term is x squared. We split it up into x squared and x squared. So then I look at the rest of this problem very similar to what we've done before. We have a positive 9 here, so that means the signs are going to be the same. Look in the middle, that means they're both going to be negative. Factors of 9 are 1 and 9, or 3 and 3. Which ones of those will give me 10? 1 and 9. So at this point, we talked about this the other day in class a little bit. At this point, x squared minus 1 and x squared minus 9, technically, if you are solving, you could go ahead and set x squared minus 1 equal to 0, add the 1 over, take the square root, and you get x is equal to plus or minus 1. Take x squared minus 9, set it equal to 0, add the 9 over, take the square root, and you get x is equal to plus or minus 3. You could do that because you know how to solve things that are that simple. But you also need to be able to factor things that look like x squared minus 1 because that is a difference of 2 squares. The reason is because of some things that we'll also look at later in the year with things called rational functions. So you have to be able to split that guy up into x and x, plus and minus because it's a -1, and 1 and 1 are the only factors of 1, and that'll cancel out the middle because 1x and -1x. The same thing with x squared minus 9. It is a difference of squares also. X and x gives me x squared, plus and minus gives me -9, and 3 and 3 would cancel out, 3x and -3x in the middle. So you do need to be able to factor this all the way, even though technically you could have solved it from here a little early. But even if you didn't, you'll notice that if you set this equal to 0 here, set this equal to 0 here, set this equal to 0 here, set this one equal to 0 here, you will get -1 for an answer, +1 for an answer, -3 for an answer, +3 for an answer, which is the same thing that we got when we stopped a little early. So when you are solving, there are times when you can stop a little early on your factoring if you already know how to solve these little parentheses. But you do need to know how to factor something completely. And that will come into play, like I said, a little bit more later in the year. So if you need to go back and review the sum of two cubes and difference of two cubes, remember there's another video on those. And I mentioned when you factor something like that, solving is going to be a lot more tricky because you're going to have to use the quadratic formula probably on something like this. Sometimes also you'll run into an old quadratic that you can solve using something called completing the square or the quadratic formula. So in this particular one, I'm actually going to show you both methods. I'm going to show you the quadratic formula and completing the square. So we'll do orange here from completing the square. So at this point in the video, if you remember how to do completing the square and how to do the quadratic formula, you might can kind of skim through this part. But if you don't, it'd be a good review. So completing the square says I take this x squared plus 6x and I get it by itself by adding the 17 over here. The reason is because completing the square means we are going to take something that has 1x squared and the middle bx term is divisible by 2, and we're going to make it be a perfect square. Thus the name completing the square. So we're going to make something be a perfect square here by adding the same number to both sides. Particularly, the way we get that number, and the reason you want the 6 to be divisible by 2, is we divide 6 by 2 and square it. So what is 6 divided by 2? Well, 6 divided by 2 is 3. Then we square that. So what is 3 squared? 3 squared is 9. So 9 is what I'm going to add to both sides. My reason for doing that will happen here in just a second, but 17 plus 9 is just going to be 26. So we won't have to deal with that anymore. We'll just go ahead and add it together. The reason for adding this 9 is because now this thing is one of those perfect squares we talked about where both parentheses are exactly the same. And it's going to be x plus 3. Do you notice that the 6 divided by 2 was 3? That's going to be the same thing that I get here. That's called completing the square. It's making it be a perfect square. But the whole purpose for completing the square, this is what we do to make it be a perfect square. The whole purpose is now I can solve this thing using square roots kind of like we did on the other ones. So we take the square root and we get x plus 3 because it's a perfect square equals plus or minus the square root of 26. Now, again, I'm not going to do a whole entire review on radicals. You can go back and look at square roots and how to simplify radicals of square roots. 26 you cannot simplify. The only thing I can do now is subtract the 3 over, and I told you guys I typically like to put it in front of the plus or minus. So here's your answers. You could also use the quadratic formula on this one. Remember, the quadratic formula is used to solve things that don't factor also. So just like completing the square, it's another way to solve quadratics. But it's used when you get to things maybe a little bit uglier than 1x squared and 6x. But you can use it on any of them as long as you know the formula and what's A and B and C. So let's sing the formula one more time. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. So now we're going to take it and we're going to use our formula to find our solutions here. So you use your formula and you plug in the spots. Remember, b is the number beside the x. That's the 6 in this case. A is the number in front of x squared, so we're going to use the 1. C is the negative 17. That's the constant term that we talk about. Now on the outside, you should have a negative 6 here, plus or minus. On the bottom, you should have 2 times 1 is 2. And then on the inside here, you have 6 squared minus 4 times 1 times negative 17. Now, I probably should have done this before I started the video, but I'll open up a calculator real quick so you guys can see what I'm actually talking about inside the radical. So inside the radical, you can take all of that stuff that you see in there, the 6 squared minus 4 times a times the 1 there times the c, which is negative 17, and you can multiply it all out and do your subtraction there, but notice that a positive or a negative times a negative makes a positive 104 here. So you get 104 inside your radical. Now that doesn't look the same as this answer over here. That's because it goes into that simplifying of the radical. 104 can be split up into 26 times 4. Now I didn't choose 26 just because I knew the answer over here. It's because I knew that 4 is actually the highest perfect square that divides into 104. I did a little bit of math in my head. You could probably use the calculator. But 4 is a perfect square. What is the square root of 4? 2. What do I do with the 26? It stays on the inside because it's not a perfect square. But this still doesn't look the same, but look at what happens. What is negative 6 divided by 2? Negative 3. What is 2 divided by 2? 1. So you have 1 square root of 26. So either way, you still get the same answer for both of them. So there you are. There's a little bit of review on some factoring and solving. So you got a little bit of quadratic formula completing the square as well as your factor by grouping. You're factoring by the quadratic form. And then if you ever need to, like I said, you can also go back and practice your factoring with a sum of 2 cubes or a difference of 2 cubes. Just remember solving these is going to be where you use that quadratic formula most likely.